Hi, it's me again. Welcome to the module on large language models. We're going to talk about just, I promise, high level limitations. Where can they go wrong? Application techniques. So, this is how LLMs are applied in software in building applications for actual use. So that if you are in the situation where you're using one, being asked to evaluate one, trying to understand what all the buzzwords are and the fun presentation on what this does and how it works, you can sort of see a little bit behind the veil, understand what those capabilities should be, and what those limitations might be with different techniques. We'll talk specifically about healthcare applications and then just a few practical tips. So, what is a large language model? Quick, brief background. This came out of a field called natural language processing and data science and research in general. The point is to interpret human language. There's a lot of human language in the data. A lot of it very unstructured. It's just free text. How can you get information from that? You have to extract, for example, meaning from certain words, figure out the sentiment behind a tweet. Understand within the context, people can say, how to dose a drug in several different ways, and you want to just extract the data that you need. How can you train a model to be able to understand all the different ways that a human can put together a sentence that basically more or less means this patient got insulin, so that you get the relevant information where it is basically hidden inside of the text. Then along came Transformers, 2017-ish, I think the paper was published. It sort of changes the way that these language models were able to interpret the context around them. And we'll talk about that in a little bit. And the application of Transformers, the performance got so good that companies started throwing more and more compute resources at it. Of course, they were always giving them resources, but not to the extent that they are now. And it's because they demonstrated that if you put a lot of compute resources to it and train it on larger and larger amounts of data, you actually get very, very good. And that's where we are now. Now we have really, really pervasive, popular generative language models that are in everything. So just core concepts that you need to know. An embedding is the process in which we take a word or a token, a word, a series of words, and transform them into machine readable numbers. Machines can't actually read. You need to convert them into numbers. We can't do statistics on words, but we can do statistics on numbers. We're basically just like assigning unique keys to specific words. We do math on these input embeddings, basically very, very fancy statistics to find associations between them. The main thing that Transformers brought, which I explained to you earlier, is being able to look at context more effectively around the word. So the example that gets brought up all the time is the word bank. It could mean a place where you put money, or it could mean like a riverbank. And a great way to tell which one you mean is by looking at the context, the words around it. If you're talking about being out in the woods, it would be super, super weird if you were actually referring to the bank where you put money. It's not impossible. And you can imagine a bank in the middle of the woods or something. So it's there. But the probability is relatively low, which is what these models are doing. They're generating probabilities on how likely is it that this word is the one that we're talking about? How likely is it that the word that follows this word is going to be this or that? And it takes into account in both the training and in the generation, the context of the words around it. How do we access these? There are multiple different providers. There's Claude, there's ChatGPT, there's Gemini from Google. You can go on Amazon and they'll have a bunch of, fun open source models and sometimes even some closed source models that can run in their cloud that you can access. Within each of these providers, there's lots of different models that you can use. There's, different size models, different quantizations. They each have sort of different capabilities. Like Google, for example, has many, many, many different models. So does ChatGPT that you can use. Some of them are very, very large. They take a long time to produce the things that you ask them to do. Some of them are connected to the internet and can query things. Some of them are not. Generally, larger size models perform better than smaller size models. So you need to consider, things like how quickly do I need to generate, the output? If, speed is more important than accuracy, or if the job is very, very simple and you don't need a big, huge model to figure out the correct answer, use a smaller model. It's faster, it's cheaper, probably better use of those resources. And then, most familiar to most people, how you access it through like a chat interface. It's like you're talking to someone, you can type into it, ask it a question, whatever. But programmatically, the way you'd use an API where you send these things through your program just to the server. It comes back in whatever form it comes back in. You might have to format it, reformat it again, and then output it in the way that you want. Might need some cleaning. But that is generally how you access these. And then last thing for this part is the limitations. So like I mentioned before, there's problems with them, and we should talk about them to like the extent that it applies to us in healthcare. So hallucinations, really, really, really big issue. It's not really a hallucination. It's not like lying to you. Like it's just choosing the next most probable set of words. They are not optimized to tell the truth. The truth to the LLM is a meaningless concept. It was trained on huge corpuses of, all text in the internet. People say things all the time. It's not even necessarily pulling from incorrect stuff. It is merely just putting together sentences that make sense. A lot of the times, based off of just the structure of the human language, if two things very probably go together, it's likely that they're correct, but it is not guaranteed that they are correct. And this is, one of the big problems that we've been trying to deal with. And we'll talk about how people are trying to deal with this later on in the course. But hallucinations, what's commonly referred to as hallucinations, happens all the time. And then there's biases. This is when, there's sort of a subset of hallucination. It's going to give you answers based off of the stuff that it was trained on. And if, you train it on a bunch of incorrect stuff or train it on a bunch of stuff that has a lot of opinions which perhaps we don't want, coming out of the answers, well, too bad. It's going to come out. It can come out. There are certain guardrails that you can set up to try and prevent that, but basically everybody gets around them eventually somehow. So those are there. Very, very similar to what happens in statistics. Your output is only ever as good as your inputs. Your inputs are always going to be biased in some way, but even more so with large language models because it was trained on everything. So like I alluded to before, there's problems with resources and speed. They use up a lot of energy. They use up a lot of data, use up a lot of compute time. So when you're building an application, thinking about which model that you need to use, you need to think about the balance between speed, cost, and like the quality of the output that you want. Like you don't need a reasoning model to do every single task. You can use smaller models for smaller things and it costs less and it's faster. There are context issues, and this is slightly different from hallucinations, but the way that large language models work is they're recursive. So then you give them your block text of this is the thing that I want, and then it only is generating one word at a time. What is the next most likely word that comes after this blurb asking for something? And it's going to be like the first answer of, the first word of the answer, which is usually something like, this is a great question. And then yada, 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 it explains, and then it keeps going word after word. But what it's doing is it's generating that word, tacking it on to what you gave it, and then feeding that back into itself. And it's like, okay, cool. What's the next word that comes after that? And then feeding that back into itself. Okay, what's the next word that gets into that? And you can see the issue here is that the amount of words that you're feeding back into it is growing word by word as you keep giving it stuff. We'll talk about this a little bit more in the application section. There are things that where you are injecting a lot of stuff into the prompt. This is going to fill up the context window of the large language model. This is a limited resource for a lot of large language models. A little bit less so for the really, really large frontier models. But for smaller models, like I alluded to before, it is an issue. You have a limited amount of context that you can give these things, these large language models. Even large language models that have really, really large context issues run into a problem called loss in the middle, where you give it a long set of instructions, like 10 things that it needs to abide by, it'll forget because it's buried in the prompt and it won't pay attention to it. And again, we're anthropomorphizing, but it's just that it's paying attention to the words that it's generated and it's not thinking. It's just creating words. Adding things into the prompt helps a lot, but it's not a boundary. It's not a constraint. So then it's called the loss in the middle problem, where it starts to ignore the instruction that you gave it. And then, of course, privacy. If you use one of their chat features, they tell you, and they will use all the things that you put into it for training to make their, the LLMs better. But then also they can do whatever they want with your data because it's just part of the data use agreement. So this is a thing that we'll bring up again later.